Record button. I'm recording on my computer. So there is, much option to it. So anybody has any questions before I start? So clicking on the record button, sharing the screen here, sharing the screen. So you can see it now. So I'm going to take off this for the panel, right? Escape. Make it smaller. Make it smaller. Make it disappear. Video panel is taken off. This floating panel is also taken off. So both panels are taken off. So I'm going to go to the lecture notes. So if you look at the lecture notes here now, so we have the reliability. In the last lecture class, I completed the reliability. So like I told you that I will update the lecture notes, I did, and I posted on the web page to be very, very clear about MTTR, MTTF, MTBF, and MTTF. Time to fail is basically the minute you started the product, and when is it going to fail? It's time to fail. That means the time it is ready to use to the time it fails is MTTF. So MTTF is basically time to fail. So the minute you bought it, okay, you started everything is fine. So it's going to fail here. So that is a TTF, time to fail. So after it fails, for example, you need to repair it. So repair, time to repair. And again, it's going to fail somewhere here, right? So from this place is ready to use to this place, it is actually going to fail again. So, good. So fail, good, and fail. So good to fail is your TTF, time to fail. So fail to good is the time to repair. The total time between fail to fail is, okay, fail to fail. Between failures, TBF, time between failures. Time between failures. So mean, you can find out always the mean value. So MTTF, mean value is MTTF. So MTTR, mean time to repair. And MTBF, mean time between failures. So basically mean time between failures equal to mean time to repair plus mean time to fail. So that uptime is this one, downtime is this one between failures. This is the total time. Your availability is MTTF divided by MTBF, which is MTTR plus MTTF. So this is availability. So I actually updated this lecture notes on the web page, already. So I did show you here the same slide. I actually made a new slide for you. Okay. And then I actually posted it here. We just got it here. Time between failures, time to repair, time to fail again. So mean time between failures equals to mean time to repair and mean time to fail. Availability is mean time to fail divided by, this is the uptime, right? So, and mean time. So is it clearly understood? I added this slide, I think, to improve the, your understanding. Anybody has any question? So I'm going to go to the next lecture here, which is decision analysis. Before that, we want to look at the probability review of probabilities. So basically, you have the knowledge, which is posterior probabilities. A priori probabilities that you already know beforehand, before even conducting the experiment, you already know what will happen. That is a priori probabilities. For example, you take a fair coin, so it's going to give you this, heads is going to be 0.5, tails is going to be 0.5 also. So that is, a priori probabilities. At the beginning, you know some knowledge about it. So given that knowledge, you can find out what happens. So, based on the experimentation. So you can do the experimentation after that. So basically here, right, in the review of probability, you must have studied it somewhere else. So basically Bayes theorem. Bayes theorem is probability of a given event and a probability of an event given another event equals to probability of the other event divided by given the other one multiplied by probability of A. So divide by probability of B. This is the Bayes theorem. This is the called total probability. Okay. This is the total probability. All right. Total probability. So basically total probability of B equals to, it depends on all events. Probability of B given A1 multiplied by probability of A1 plus probability of B given A2 multiplied by probability of A2. So all kind of A1, A2, A3, A3. So do all of it, that is the probability. This is the total probability. Basically, this is the intersection. So probability of B intersection A1 plus probability of B intersection, okay, A2. So like that. So it's basically intersection of all the other events that are, so intersection of B with all other events is the total probability. This is a Bayes theorem, and then this is very important. So that means here, whatever you're writing down, it can be expanded using this formula. This is Bayes theorem. Okay. This is the total probability. This is conditional probability. Okay. This is the, a priori probability, and then posterior probability, like that. You can say conditional probability. So if you take, there are 6 phases of, a fair die, a die, a fair die. Die is basically. So when you take 2 of them and then roll them. So you can have 1, 2, 3, 4, 5. So probability of each of them is 1/6. You take a card deck, for example, probability of getting a, diamond ace equals to diamond ace. There is only one ace, diamond ace, 1/52. So probability of getting a ace, 4/52. So like that, right? So this is a card deck. The total number of cards that you have is 52. So a simple event is just like taking a red card or something. Red card, how many red cards you have? 13 of them. So between 52. So that is the probability of getting a red card. Okay, if you're taking a ace that is also red, there is only one card like that, 1/52. So you already know. So again, I want to show you here. So this one, right, basically equal to probability of B intersection A divided by probability of B. So you can also write like this. So probability of A given B equal to conditional probability A given B. So intersection, this is intersection. Okay. So probability of A given B, so multiply by probability of B. So basically probability of B, okay, that is the, intersection. So you can also write the same thing as probability of B given A multiply by probability of A. So this is intersection. So these formulas should be known to you by heart almost. So because that's, conditional probability based theorem. You must have studied it in other courses. So red card, black card. Oh, red card, there are 2 of them, right? It's not 13 alone. So it's actually 26 of them, right? So black card, sorry, my mistake here. So it's not 13. Red card is 26 of them, right? Isn't it? Am I right or no? Please. The hearts and the diamonds, right, are red. The clubs and the clubs and I don't play cards, so that's an excuse. Okay. So A is an event, A complement. So that means A is happening. So, okay, our success. So A dash is failure. So A complement. So doesn't happen. So probability of A plus probability of A complement equals to 1. Guaranteed. One of them is going to happen. Okay. The queen of diamonds, A complement is not queen of diamonds. So not. So ace, not a ace. So there are 2 aces like that, right? Isn't it? Red card, aces, this is diamond ace, and then, hearts ace. Again, in the black card also there are 2 aces, not a ace. Okay. So how many cards are remaining here? 24 of them, 24 of them, not a ace. The full deck. So you will be able to find out here, right? So if you take the card deck, probability of getting an ace is 50%, which is not red card. Red card is 50%, which is 26 divided by 52. You understand, right? So you take here, there's only 2 of them here, right? 2 by 52. So you're taking. So, you can also say that it's a given probability. So probability of getting a yes, given it is a red card. Probability of getting a yes, given is a red card. That's what you want to find out. So probability of a red card, okay, given a yes, multiply by probability of a yes, divide by probability of red card. Okay, you can also do like this. Probability of yes given red card equals to probability of red card given a yes. If you know, you have to know this. You have to know that. Okay. So if you want to find out, right, probability of red card is given a yes. So R intersection. This is basically, this is nothing but red card and yes intersection. This is basically red card. Red card, you already know what it is. Okay. Black card, you already know what it is. And the probability of yes, you already know what it is. Okay. Probability of yes is basically 4 divided by 52, right? So if you know that is a yes, and then, red card is going to be like a half of the probability. Okay, you have here certain means guaranteed. This probability of happening is probability of impossible, like, probability doesn't happen, like, like impossible event that cannot happen. Okay, so its probability is 0. So sum of all probabilities is 1. Okay, anybody has any question, please stop me. So number of outcomes. So this is intersection here, right? A intersection B, and both A and B are present in those outcomes. Okay, both. This intersection means and. Union means R. R means plus. Intersection means multiplication. Okay, you already know this, I think, right? So probability of possible outcomes in the sample space. This is the total probability, right? So that means all possible, the number of possible outcomes in the sample space. So the total number of outcomes is 52 cards. You have 52 outcomes. Only red card, that is the yes, is only 2 cards like that, 1 by 26. Okay. So union is like, plus. So the probability of A, R means plus, R both. So basically A or B, which means that both also is here. Okay. So the intersection, so when you have like this, probability of A plus probability of B minus probability of A intersection B. Why, sir? Why are you subtracting this one? So probability of A, for example, look at it. Probability A, this is A, this is B. So this is the intersection. The probability of A, probability of B, probability of A intersection B. So if you take a probability of A is this one. Probability of B is this one. So that means you have this part in A as well as B. But when you take union, this is the whole thing. The whole thing is the whole thing. A union B equals to probability of A plus probability of B. So you have 2 times this one, right? This is 2 times. You need to put only 1 time. So that means you need to subtract 1 time. So that's why you subtract it. So probability of, what is it asking you here? Red card or ace. So probability of red cards is 26 of them. And the probability of ace, 4 of them. But you need to subtract ace and the red card, which is 2 of them. So which is 28 divided by 52. Anybody has any question? You can also write down an event which is A and B, an event which is B and C. If you want to really say probability of A1 and B1, probability of A2 and B1, add them together is probability of B1. So B1, B1, B2, B2. So probability of B2 and add them together. When you add these two together is probability of A1. So add them together, that is a probability of A2 because A2, A2. So the total probability, this together is 1, this together is 1. You can, if you write like this, it'll be a lot easier for you to actually figure out the conditional probabilities because, conditional probabilities are basically coming from, I'm going to write down conditional probability for you. Probability of A1, okay, given B1 equals to probability of A1 intersection B1 divided by probability of B1. So that's it. So you can even write down the same one as probability of B1 intersection A1 divided by probability of B1. You can A intersection B, A1, probability of A1 intersection probability of B1 intersection B1 equal to probability of B1 intersection A1. So I'm review, basically what I'm giving you is review. Okay, all right. You can even write down the same thing as the probability of A1 given B1 equal to probability of B1 given A1 multiplied by probability of A1 divided by probability of B1. So this is the total probability, right? This one you can write down probability of B1 equal to probability of B1, okay, intersection A1 plus probability of B1 intersection A2. So if you have A3, A4, A5, you can even write down all of them. So basically, it is a B1, it is a B1, it is a B1. I hope you understood them. So you can even expand this one like a conditional probability, if you want. What is it, sir? Conditional probability, probability of A1. Okay. So intersection B1 equal to probability of A1 given B1. So multiply by probability of B1. So look at here, take this one formula. So A intersection B, A1 intersection B1 equal to probability of A1 given B1 multiplied by probability of B1. So you need to understand this very clearly. I'll give an example again, right? So this is a conditional probability. So the red card given that is a yes, okay? Red card that is given that is a yes. So there are two red cards, red aces. So the given that is yes, there are four aces. Okay. So that is a probability of, half a probability. All right. So if you take the color cards, right, you have the red color, 26 of them. You can write the probabilities or the outcomes. It's the same. Black card is this one. So probability of black card, yes, there are two non-yes, 24, 24, 48. So add them 52, add them 52. So you know what? Probability of yes given red card equal to probability of yes and red. So yes and red is 2. Okay. And the probability is divided by 52. Okay. Probability of red card is this one. So 2 by 26 is the probability of yes given red card. So conditional probability, like I told you already, this is the same formula I was writing down earlier. So you take this one and then you take this one to the other side. So you get this formula. So this one, if you want to revise it, B1 to A, and this will be A. So probability of A given B equal to, okay. So if both are independent, they are not dependent on each other. So A is here and B is here. So intersection is 0. You understand me? So that means it's not really like, for example, so it is going to be 0. The intersection is basically 0. Intersection is 0. So probability of, okay, A given B, because it doesn't depend on B, the conditional probability of B, a probability of A. So this one is again same thing because there is no intersection. So you are actually writing down this. Okay. Anybody has any question? A and B. So just multiply them because so they are independent. So one event is not affecting the other event. So only if it affects, then you will have intersection. These are intersections. So X is the event, A is the event. Okay. Probability of A is the total probability. A. So, adding all of them. So basically, this is nothing but this. This is nothing but this. So converting into conditional probabilities. Either way you do, you get the same answer. This is called Bayes theorem. So basically, probability of event given probability of B given A equal to probability of A given B multiplied by probability of B. So divide by probability of A. This is the Bayes theorem. Okay, this is the total probability I told you. So probability of A here, you can rewrite again. How, sir? Probability of A intersection B1 plus probability of A intersection B2 plus probability of A intersection B3. You can keep on writing like that. So you can even expand this one. Probability of A given B1 multiplied by probability of B1 plus probability of A given B2 multiplied by probability of B2. So like that, you keep on writing down all of them, you get the total probability. So conditional probability, so, posterior probability. So one is posterior probability. So Bayes theorem is going to allow you to calculate the other, which is if you know A given B, then you can compute B given A. So let's take a, 50% borrowers are repaying. So that means 0.5. So probability of repaying is 50%. Probability of not repaying is also 50%. Out of those, who repaid? So it means that, so our college degree, probability of college degree, given that he repaid, equal to 0.4. You understand me, right? Probability of repaying equal to 0.5. You understand, right? So 10% of those defaulted, that means they did not repay. Okay? Have a college degree. Okay? So have a college degree. 10% of them who actually, probability of getting a college degree, having a college degree, given that it did not repay, equal to 0.1. So this is given to you, this is given to you, and is given to you. So what is it asking you actually? So probability randomly selected borrower who has a college degree will repay. So he has a college degree, will repay, he has a college degree. So he's asking you to find out that. Okay. So what are you asking you? So probability that he has, okay, he has given that he has a college degree. So this one, how do you write down? Probability that C given R multiply by probability of R divided by probability of C. So that's what it is. Okay. So you can even write down the same story. So you know this, you know that. So probability of C, you need to find out. So I'm going to, so that means 0.5. No, 0.1, 0.1. 0.1 multiplied by oh, sorry, my mistake. 0.4, 0.4. 0.4. So probability of C given R is 0.4 multiplied by 0.5. You understand, right? So divide by probability of college degree, okay, given repaid multiplied by probability of repaid plus probability of college degree given he did not repay multiplied by probability of, okay, he did not repay. So if you know this is the probability of 0.5, probability of did not repay equal to 1 minus probability of repaying, which is 0.5, which is 0.5. So it will be like this one you already know, which is 0.4. This one you already know, which is 0.5, plus this one is the probability of college degree given he did not have 0.1. The 0.1 multiplied by 0.5. So you evaluate that, you get that answer. So look at there, 0.4, 0.5, 0.4, 0.5. Let me take out the video panel here so that you will see it. So 0.4, 0.5. So you understand this, yes or no? 0.4, 0.5, 0.1, 0.5, 0.4, 0.1, 0.5. Is it clearly understood, yes or no? So you need to actually formulate the problem very clearly, and then we'll be able to use the Bayes theorem. So that is a review, not really a teaching thing, but a review for your probabilities, which is expected to be known to you in the first place. Anybody has any question? Anybody has any question? The lecture notes is already posted on the web page. So moving on to the next topic here, if you agree with me. You're okay? Someone please? You're following me? Yes, no?
Yep.
Thank you. So now we are going to look at the decision analysis, which is like, break-even analysis. So there are so many analysis that you have in decision-making process. Okay, break-even analysis, net present value analysis, Black-Scholes analysis, linear programming, sensitivity analysis. There are so many analysis in the, in the theory and, payback period analysis. So there are so much of analysis you could do, and all of them should be telling you the same answer. Then you will be following that particular, decision is good or bad. You will be able to decide. Okay. So decision analysis. So break-even analysis. So decision tree analysis. Decision tree. Decision tree is like starting from here. Maybe you do that, maybe you do that. You know, if you do this, it will happen. This one, this can happen, this can happen. If you do that, this can happen, that can happen, this can happen, like that. So rectangle is an alternative. So basically, circle is an outcomes. This is the notation for the decision tree analysis. Okay. So alternatives are not probabilities. Either this or that. You're buying a small car or a big car. You are buying only one car. If you take a big car, this can happen, that can happen, this can happen, like that. These are outcomes. Value of information. If you know without information, what will happen? With information, what will happen? So that is a value. The difference between that is the value of information. So value of perfect information. When you have information, you make the right decisions. So best of all probabilities you can take when you have the information. So though the capacity planning decision you can make. Okay, capacity is defined as the maximum production or throughput rate. Maximum production or throughput rate. So maximum production can be ideal or under normal conditions. Okay, measuring the capacity, trying to understand the break-even analysis. That means when are you getting your money back? Where the overall profit equal to 0. So at the beginning, you are investing on the fixed cost, the machines you are buying, are renting. That is called fixed cost. And then you're buying direct materials and direct labor, direct material and direct labor, direct labor. So these are put together is variable cost. So for each item, there is a variable cost. So VC multiplied by the quantity that you're producing is the total amount of variable cost. So plus fixed cost. This is the total cost. Okay. So when if you're producing Q, and how much revenue are you getting? For each item, the price is P. So P multiplied by Q. So that means Q is break-even quantity. When the total cost is recovered, this is the revenue. This is the cost, the total cost. So if both are equal, so that Q is break-even quantity. So which will be Q break-even quantity is called break-even point equals to, you look at the other one, look at it. So what you will see, the fixed cost, so divide by price minus variable cost. You take this one to the other side and then take the Q common. So P minus VC multiply by Q. And you take the Q only one side. So fixed cost divided by, this is a break-even point. So your capacity is bigger than the break-even point, you make money ultimately. Your capacity is lower than your break-even point, you're losing money. Did you understand? So design capacity, a system is created. You know what? Ideal conditions don't happen all the time. People take breaks. People become sick. Machines get broken. So ideal condition means machine is not broken. Okay. People are not taking any sick days. Everything is happening exactly as you think is supposed to happen. That is ideal condition. That is a design capacity. But design capacity is not always possible. Effective capacity is taking care of normal conditions. This is ideal conditions. This is normal conditions. So that means people are taking breaks. Okay, you are not producing one item, but several items you're producing. Scheduling difficulties, equipment maintenance, make it breaks, delays, employee breaks, breaks. So standard output rate you take. This is a standard output rate, not ideal output rate. So measuring the capacity, you would like to think about efficiency and utilization. Utilization is the uptime. See, the total uptime divided by the available time. So that is the utilization. So much time is available to you, but how much are you really using it is utilization. A machine is actually in operation. That means, machine is given to you. You may use it, you may not use it, but it is available to you. So actually, you're using it, divide by the available time utilization. You would like to have 100% utilization. The minute it is given to you, the machine, you want to use it right away. So efficiency means cost effectiveness. So efficiency is going to increase the actual output rate given the effective capacity. Effective capacity is the capacity which is under normal conditions. So capacity, that means ability to produce. What is the capacity? Can anyone define, please? Ability to produce. Okay? That is the capacity. Effective capacity is normal conditions. How much do you produce? It's like a throughput rate. So actual output rate may be the same, then efficiency is 100%. The actual output may not be exactly what you would supposed to happen. Then you are not really doing efficient. Is it clearly understood? Yes or no? So utilization is uptime divided by the available time. So if you take, this is called bottleneck. So, bottleneck is limiting. For example, you have a pipeline here. You have another pipeline here. All of the pipelines are coming here and joining here. Okay? So there is another pipeline coming here. So it's producing 10 per hour, or 10 items producing here. And the 10 per hour, 10 per hour. So it's coming to 30 per hour. Do you agree with me? Or still like 1, 2, 3, 4. It's coming to 40 per hour. But what is coming out of the bottleneck here? Can you tell me how much it is? 30 per hour. So bottleneck is limiting the entire sequence of operations that you have before. So for example, here, this is 5 per hour, 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 this is 20 per hour. You understand me? In this case, what is coming out of is not 30 per hour, it's 20 per hour. Maximum you can get is 30 per hour because the bottleneck has a limitation. Is it clearly understood? Bottleneck analysis. So bottlenecks must be eliminated in the process. Identify the bottleneck and put more resources so that you will be able to do well. So total cost equals to fixed cost multiplied by plus variable, the total variable cost. This is the total variable cost. I actually put in earlier VC as a single variable cost. He wrote down total variable cost. Okay? Total variable cost equal to variable cost multiplied by the Q. So variable cost is what? Direct material cost plus direct labor cost plus overhead cost. Can you tell me the difference between them? Direct materials are the direct material that you use. Direct labor is the people who are working there. You are paying salaries and all, that is what it is. Overhead is the managers, the sweepers, the energy, the electricity, water, the facility, like facility maintenance, not fixed cost, but maintenance cost, or even a supervisor salary, and all that is indirect cost. Overhead cost is the indirect cost. Did you understand clearly what I said? Hello? For each item, there is a cost. Material cost, labor cost, and overhead cost. For each item, you can quantify that item cost, that is V. So multiply by Q is the number of items you're producing. Okay, you're producing. It could be more than your capacity. It cannot be more than your capacity of the machine or something. It will be less than your capacity or equal to the capacity. So you will look at here, the variable cost is Q multiplied by V. Total revenue that you're getting is R, is the price of an item multiplied by Q. So total revenue minus total cost is the total profit. It is dependent on the Q. It is dependent on the Q. So PQ is the profit when you produce Q. So Q equal to P plus FC divided by R minus V. You understand me? So Q, the profit here, right? Look at the profit here. If profit equal to 0, if the profit equal to 0, that is break-even quantity. If profit is not 0, so which means that, you will have producing more items than break-even. Is it clearly understood to you? Yes, no? Okay, all right. You're not talking. I hope you're following. So the revenue, if you don't produce anything, this is a Q. You don't produce anything, so that is the total revenue. And the total fixed cost is this. This is fixed cost. And variable cost is on the top. This one is fixed cost plus Q multiplied by variable cost. This is the total cost. So both of them are intersecting here. Before that, you are losing money. After that, you are making money. Your capacity is more than your break-even point. You are able to produce more. Your demand is more than your break-even point, then you are able to sell the item. The difference between demand and capacity. Can anyone tell me, please? Demand is the amount of items you are selling. Capacity is the amount of number of items you are able to produce. So your demand must be greater than your capacity, then you are able to fully use your capacity. Your demand is less than your capacity, you are not able to fully use your capacity. An example here, the fixed cost per month is 6,000. Okay. And a variable cost V equals to 2. And the revenue here R is price of an item is $7. This is a fixed cost. Okay. What is he asking you? How many pies must be sold per month to be break even? So how many actually should you produce? Q break even point equals to fixed cost divided by, so price minus variable cost, which is 6,000 divided by 7 minus 5. So basically 1,200. So those many pies you need to produce per month to be break even. So what would be the profit if you sold only 1,000? You will be losing for sure, because the total, you should produce at least 1,200 and sell them. Then only you will be able to get the break even. You get your money back. You're not making any money. So what would be the profit if 1,000 pies were made and sold in a month? So what will happen? Only 1,000 you sold, the profit equal to Q multiplied by the profit for each item. So price minus cost is profit for each item. And you need to pay for the fixed cost also. So this is $5,000 minus $6,000 is $1,000 you're losing. So how many pies must be sold to realize the profit of 4,000? So that means, remember you have the formula for this one. Q equals to profit plus fixed cost divided by R minus V. So profit is 4,000. Fixed cost is 6,000, which means 10,000. And the 7 minus 2 equal to 5. So that means 5,000 items you need to produce to be able to get a profit of, see here. Oh, 5,000. Did I put 5,000? How did I put 5,000? 10,000, right? 10,000 divided by 5. 10,000. I think I said 5,000, but it's not 5,000. It's actually 5. So it's 2,000, right? 2,000 pies. Sorry for that. So 2000, put the formula right now. So you know what, if you produce only, so that means how much profit, is it a good investment? Because it's more than 1200, 1200 was a break even. So that means it is a good investment. Anybody has any questions up to here, please? So you're not really producing one item, you're producing multiple items. So one item, I equal to 1, 2, 3, 4, like that. So the price of cost of an item, price of an item, and a percentage of your business there, the weight. So sum of all the weights should be 1. W is like a weight. So let's check here. W is a portion of the revenue, like a weight or index or, okay. So what is the break-even point in terms of dollars? It's not the number of items here, the number of items here. The difference between, here, when you have multiple different items, what you can convert them to all dollars. Okay, the quantity. So then you will be thinking about dollars, not items, because you don't know which item to produce. Okay, so such an example I'm going to give you again. I want you to look at it. I'll be back in 1 minute. I'll just go to, okay, I'll just come back in 1 minute. I want you to read it. So we are around 15th slide, right? So we have around 50 slides. After that, I'll leave you. Okay, one minute, I'll be back. Thanks. Okay, all right. So we are coming again to continue here. So I'm continuing here from here. So manager has a bakery, uses equipment for, to make a quiche, right? Quiche will have a variable cost of $3 and it's going to sell $10. So V1 is $3. the P1, the price of an item is $10. So this one is making pies also, right? Alternatively. So, and, $2, V2 equal to $2 and R2 equals to, okay, is $7, the price of an item, R1, R2, okay. So the cost of leasing the special equipment for the quench and the pie, R pie, right? So it's going to be $6,000 per month. Calculate the break-even point in dollars because you're producing two items for the same machine. So use the formula that I gave you earlier, which is, you use the V1 R1 formula, right? And the weight here is not given to you. Which one is proportion is not given. So equally put a proportion. When it's not given, use the equal proportion, which is W equal to 0.5 for each item, right? So 50-50. Okay. So sum of the items, so sum, right? Here, look at the sum of the items. The whole thing you do for each of the items and then sum them up. Okay. So look at here now. This is one factor. This is another factor. So remember that it's like a weight. This one plus that one should add up to 1. Okay. So because it's not given, so you put 0.5 for each of them. So the formula is V divided by R is 2 divided by 7 and 3 divided by 10. I just use the formula that is the break-even point for in terms of dollars. That means you are spending the fixed cost, which is $6,000. So to get the money back again, you need to get at least this much of money to pay for not only the fixed cost, but also your variable cost. Because at least direct labor, direct material also is a cost when you're operating that machine. So that has to get it back to you. Otherwise, you will not really get your money back, right? So intuitive, quick approach doesn't always work. Uncertainty is uncertainty. So what is suggested is first you need to make a decision maker to influence the decision to see all the influences. Okay. So most people choose to do nothing. So that means another option is do nothing also is an option. There's a tendency to waste good money after bad decisions to avoid admitting to have a bad decision. So these are all the people tendency. So lucky streak is a mini case here. John is an ambitious entrepreneur, experienced in 2 consecutive terms. He made very good career, right? First venture is a small tech company startup, unexpectedly a massive profits he got, followed by second venture he did and a retail sector, also similar success. He thinking that he's a great guy now. John is convinced that he possesses the golden touch and he thinks that anything he touches is going to be gold. And then he may, basically everything is going on the market conditions, not really like him alone. So sometimes when a market is going higher, you will get more money. That's normal. Okay. So, and then he actually made more investments here with the industry with little knowledge. And he lost a lot of big losses resulted here. And then he reviewed what was done before, why it happened before. He made more profit. So economical conditions actually made the profit, not his, role in the early victories. So that's a lucky streak. Sometimes, when market is doing well, you normally do well. Okay. If market is not doing well, if you need to do, your good decisions are going to really convert to market. Melanie, a 35-year-old investor, approaching her portfolio in rather uncontroversial manner, to manage the losses. Melanie often holds the declining stocks. That's normally people use. But anything which is increasing, okay, so he crystallizes the profit right away too early. No, he doesn't. He fears to crystallize the losses, but usually crystallizes the profits very quickly. Okay, instead of holding on the winning stocks, you need to hold on the winning stocks and probably sell the losing stocks. Losing stocks may still lose more and more, right? At one point, you have to really say the enough is enough and sell the old ones. People are not really able to sell. So because people's behavior is also different. Risk averse, that means we want to really, risk averse. People are risk averse when random variable gamble, right, is in the terms of gains. So he doesn't, you think that I'm going to lose this and then sell too early. Risk seeking people, risk averse people. Okay. So risk seeking people. So when it is posed to terms of avoiding a loss. So basically this is a normally human behavior. People are overconfident sometime, right? Okay. Base their estimates in dramatic, unusual past events rather than, any reasonable thing. And the decision making process, right? So, okay, states of nature, people's nature, and different alternatives you have and a payoff. So alternative means choices. Payoff means probabilities. So payoff means this is the money that you will make with the probability. It may not be sure for sure. If it is sure, is very good. Each alternative is going to get you, okay, the profits. That is the payoffs. So list of alternative choices, future conditions. So people, okay, influence diagrams. People make decisions under uncertainty. Okay. So influence diagrams, what influences a decision? On alternative outcomes, you want to put expected monetary value. EMV means expected monetary value of a decision. And you want to really find value of perfect information. So payoff with information, payoff without information, take the difference between them is the value of perfect information. Sensitivity analysis, like what if analysis, what are the linear programming? LP means linear programming. Okay. What if you have a little bit more input? For example, you are cooking donuts. At the end, you are leftover items, material. If you have a little bit sugar, maybe you make one more donut. So the the cost of the sugar may be only 1 cent, but the donut is $2. Okay. So if you have that 1 cent, you will have probably sugar, you will have $2 profit. That is sensitivity. Okay. So modeling preferences and utilities of this, so you can create an influence diagram. It look like this. All factors that influence the result here. Look at that. This is the total result. The factors that are influencing, like a fishbone diagram. So like a fishbone diagram. Influence diagram, right? Finally, the result is coming here. So input, so many things can happen. Okay. All those are influencing. The demand is influencing, the location is influencing, the quality is influencing. Okay. Fixed cost is influencing. Expected monetary value is all payoffs you really take for that alternative, all alternative, right? You probably choose only one alternative anyway. So let's take an example here. The future demand can be either low or moderate is high. So you may take a small facility or medium facility or large facility. Only one of them you are doing, not all of them. If you do small facility, your low probability of, low demand is 0.3. Probability of moderate demand is, if you do that, this is a profit. This is a profit. That's a profit. So overall profit is a average profit is 10 multiplied by 0.3 plus 10 multiplied by 0.5 plus 10 multiplied by 0.1. So if you actually medium facility, your capacity will be a little higher. The numbers also will be changing here. So 7 multiplied by 0.3, 12 multiplied by 0.5, 12 multiplied. So this probability should add up to 1. It must add up to 1. Okay. So when you actually do that, this is a loss. That means -4. Okay. So now you actually evaluate them. Just multiplying these ones, multiply by these ones. Like a sum product, right? These one multiply by these ones. multiply by these one, multiply by these ones, add them together, the best is this one. You have a perfect information, probably you will get that. Okay? You'll take that. But you don't know which one will do. Suppose you did this one, and you with the information you get 10.5. The difference between that is the value of the perfect information, 0.5. So probabilities and payoffs. So states of nature. People are really working on the, different states, alternatives you have, and the final decision you make based on the payoffs. So payoffs are here. So alternatives, either you do that or this one. One of them you're doing, not both of them. Suppose you do this, then it may happen that maybe the probability. Some probability is there. Okay. This one equal to 0.7 maybe. If this is 0.7, that will be 0.3 because add them together is 1. And this is alternative again. Okay. And then if that the alternative, you choose this one, then the payoff this. Choose this one, payoff this. In both cases, is 0.3 anyway. So, of course, you want to take the higher value. Okay. You understand me? So far, okay? Anybody, please? Nobody is asking me questions. Choose the alternative that gives the greatest payoff. So take the example here. The numbers are given to you here. Build a small one, build a big one. Okay. So, and then the demand is 0.4, that means 0.6. Demand is 0.4, that means 0.6. But here, do nothing or expand. There are two things you do. You get this one. Obviously, that is better. This one, do nothing, I'll get minus 10 something. Obviously, this one, this is good. So now you compare both facilities. So $40, 0.4 multiplied by $40 plus 0.6 multiplied by 55. So that is the expected monetary value of the small facility. The expected monetary value of the large facility is 0.4 multiplied by 50 multiplied by 50 plus 0.6 multiplied by 70. So compare both of them, whichever is higher, that's what you do. You understand me? So far, okay? So if you're looking at here, right? So higher profit is 55. So you will take 55. So here the higher profit is 50. So you'll take the 50 and then evaluate. So that means you multiply this one, multiply with that, this one, multiply with that, add them together. That is the total monetary value of this. Both of them put together. See here, 49 and 62. So building big is better than building small one. Is it clearly understood to you? So decision tree is going to give you, okay, a systematic approach to find out different alternatives you have in the roadmap of the, decision, and the different outcomes can happen, and evaluate. Circle means outcomes. Rectangle means alternatives. Rectangle. Circle. Okay, you understand? Highest expected monetary value, that's what you take. If it is a cost-oriented the diagram, then the lowest cost you take. Expected value of the perfect information. So if you have the information, your decisions will be changing. Okay, I'll give you an example here. Okay, so best payoffs in each state. That is the perfect information. So for example, here, okay, the best one is 10, the best one is 12, the best one is 16. You understand me, right? So now you take all these three best ones and you do your evaluation. That is the perfect information. So best one is 10, probability of that happening is 0.3 plus best one is 12, probability of that happening is 0.5. Best one is 16. So this one, right? This is the value under uncertainty. Okay. So now you take any facility, any example, and you take the difference between them. The best one earlier you selected was the middle one or a small one. Sorry for that. I need to share it again. Sharing it again. So earlier you already made a decision of 10.5, but with the perfect information, you would have done the best. So 1.7 is the probability of, okay, the expected value of the perfect information. So this is how you do. So earlier you actually did, how did you do, sir? 0.5 or 10 multiplied by 0.3 plus 10 multiplied by 0.5, 10 multiplied by 0.2. That was one decision for the small facility. 7 multiplied by 0.3, and I think you got 10.5 here, right? So that you took it earlier. Okay. So let me show you again. Go back again where the slide was. I think it's the same example that we did before. Yeah, look at it. That's what you did before. So now with perfect information that which one is the best, you already know that is the best. Now you do the same math and then difference between them is the value of the perfect information. At least that's what is given to you as a definition. Okay, you can have different definitions. Follow what is given in the textbook. I know this is a little bit controversial because you have different alternatives you have. So you will be doing only one of them, not all of them. So it's a little controversial because I would redefine that as each facility given and then perfect information with that facility and improve that, like the values. So sample of information is conditional probability. Okay. You can given that, probability of B1 given A can be found out if probability of A given B1 is known to you. Okay. So posterior probability is a conditional probability. So posterior, this is posterior means after. So this one is a priori. Okay, this one is a priori, before. And the total probability. So let's take an example here, right? A fair coin you're taking. So I want to say A is a unfair coin, B A dash, R minus A. Both mean so in complement. That means if it is unfair coin, this will be fair coin. So this is the probability. So getting heads, not getting heads. So that means getting heads, given that is a fair coin. Okay, is a fair coin. So getting heads is 0.5 if it is a fair coin. So 10 times you get the heads in a row. All of them experiments are independent of each other. So 0.5 multiplied by 0.5 multiplied by 0.5 like that 10 times, right? So 0.5 to the power of 10. So we know that. So that is the probability of getting 10 heads in a row. Okay, given that it is a fair coin. So you decide to flip it 10 times. Land all 10 times. But so you want to really find out what is the probability that it is a fair coin given that you really got 10 times. So you can also find out the other way around. Okay. A is, I got 10 heads. What is the probability it is an unfair coin? Okay, you understand me? So probability of B given A, okay, new information is given to you is probability of B given A is 100%. It happened once and you think that it happens all the time. Okay. So 100% means 1. 100%. You know what? You wrote, you did it 10 times, right? You got landed all head. So you think that it's going to happen all the time. No, it may happen, it may not happen. So what is the probability that it is an unfair coin given that you get already 10 times heads? So that means probability of A multiplied by probability of, I think I wrote down earlier the formula in a different way. So I multiplied probability of A here. Probability of B given A, multiply probability of A. It's easy for you to remember. Divide by, so probability of, this is the total probability, which is probability of B. Okay. So you already know. So a priori probability 0.5, 0.5 is fair and unfair coin. Probability of B given A, okay, it is 1 because you think that is going to happen all the time. So 100%. And, probability of A, okay, unfair coin. Probability A dash is also unfair, fair and unfair is going to be 0.5. So B given A is 0.1, which is 100%. And actually happened here, right? No, we already have this earlier. B given it's an unfair coin. We already found out earlier that is 0.000. So you know what? You are not 100% all the time. This is a probability highly likely, okay, towards the heads. You understand me? Bayes theorem can be used for such information. Okay. So there are two events here. B1 is an event that employee is a drug user. So he's not a drug user. Probability of B1 plus probability of B2 will be 1. Either a drug user, not a drug user. Both will be, add them together is 1. So, and you test, randomly take a person and test him, is the probability of getting positive result for the drug usage. Maybe he is not really taking the drug. We can still probably get the drug. Okay. But less likely. So positive thing. So 93% of them, so it's 97% of that. So like a person that uses a drug and tests positive 90% of the time. Okay. And a person doesn't use a drug. So uses the drug, doesn't use the drug is B1 and B2, right? So A1, B1, B2, A plus and A plus dash. So you know what? So he's a drug user and he tested positive is 93%. Okay. And tested positive, he's not a drug user, is 97%. Yeah. Okay. Tested negative, right? Negative, not positive, negative. Tested negative. And given that he is not a drug user, he is not a drug user. Given that he is not a drug user, he is not a drug user, he is a drug user. So negative is 0.97. What is asking you to find out? What is the probability the drug user is correctly diagnosed as after testing? After testing. Okay, drug user. Correctly diagnosed. Okay. So probability that, okay, you are real. This is the probability, the total probability, like here, probability B1 is under B2, 0.05. How many people are actually the drug users? 5% of them. So 95% are not the drug users. You already know it. So what are you finding out here? So what is the probability the drug user is correctly diagnosed? Okay. After testing positive. So that means it tested positive, given that is positive. So what is the probability he is a drug user? So the probability that he is a drug user, given that is positive, test result is positive. It's very tricky here. People reverse it easily. So, but look at here, it's given to you here. Obviously, it's the other way around. Either this one or that one is the other way around. That's what the people ask you as a question, not the one which is given to you. So if you want to find out that, It's very simple. You write down the Bayes theorem. Probability of A plus given B1 multiply probability of B1 divide by probability of A plus. So that's it. That's a formula. You know that 0.93. You know that 0.05. So this one is the total probability, which is probability of A plus given B1 multiply by probability of B1 plus probability of A plus given B2 multiply by probability of B2. That's what you need to write down in the denominator. This is given to you 0.93. This is given to you 0.05. This is given to you 0.95. This is given to you in a different way. Okay, B2, this is the probability of, this is 97 for the B2. Either he is producing the drug and not producing the drug is going to be 1. So it's going to be 1 minus. So the total probability here, look at it. I'm going to go to the next one, final problem. So look at that here. So he's asking you this one, right? Isn't it? Your numerator, I already told you this is what it is. Okay. So that is 97 minus 0.1 minus 0.97. Okay. This is the total probability. What is it, sir? Probability of B1. Probability of B1 equal to, no, sorry. That is probability A plus, right? Probability of A plus is A plus. Look at it here. This is what you're producing. Okay. So A plus given B1 and probability of B1 divided by probability of A plus. Is not A plus, it is A plus. I think you should have written down like that rather than this. I don't know whether I can correct it. Let me check it. It allows me correct it because if you did something, yeah, maybe I'll be able to correct it. Go here and I do superscript. Okay, I think I'll correct it. Okay, you want me to correct it right now or later on? I can correct it later on. Okay, I'll put superscript so that A plus is not A plus. Otherwise, it'll be confusing to you, right? Is it not? A minus is like probability of A plus given B1 plus probability of A minus given B1 is going to be 1. Not these two. Probability A minus given B2 plus probability of A minus given B1. Add them together is 0.1 also. Can you repeat, sir? I'll repeat. So, for example, you know this right here. Look at it. So, probability of A plus given B2, okay? Probability of A plus given B1, add them together should be 1 because it's all cases you take. Intersection, sorry. This is the probability of A, right? Okay. A minus, I should say A minus. Okay, probability of A plus given B1 plus probability of A minus given B1 should be 1. Is B1, then it should either a plus happen, minus happen. One of them will happen. So that is 1. If I go here now, take the formula here, right? I'll write it again. The last one. I don't need to write down 3 different slides, but to be honest with you. So basically this one is basically probability of, okay, A plus given B1 multiply by probability of B1, okay, divide by probability of A plus. So that's what it is. So this one, probability of B1 given A plus is this probability. So the numerator is known to you very clearly. This one is given to you 0.93. So this one is known to you 0.05. So the numerator is known to you totally. So the denominator A plus given B1 is 0.93. We already know it also. You already know this also. And you already know this also because this is A plus given B1 multiplied by B1. This is the intersection of with B1. A plus B2 intersection of B2 for A plus. So, but this one here is A plus, A plus given B2 is 0.03. You found it because 97 was given to you. Okay. Probability of negative. Okay. Doesn't use a drug. So what was given to you? Probability of A minus given B2 equal to 0.97. So if it is B2, it is B2, either plus happens or minus happens. So 0.97 plus 0.03, add them together, it's going to be 1. So you understand how, right? And that's the total, the formula that you have. Agree? I can actually clean it up to not to really put this slide, plus on the superscript. Not the subscript, like a regular plus. I will put it like a superscript if you wish. Is it okay? You want me to do it? Superscript is better, right? Look at this. It looks like a plus. It's going to be very confusing to you. If I put a superscript, probably is better. The superscript will clearly tell you. This one is should be a superscript. Is it okay? Shall I do that? Yes or no? Are you okay? Even B1, B2 should be subscripts. But even if I don't do it, that's not a bad thing. You understand me? Yes or no? Hello? Are you there? At least one of you say yes, right? Time to time.
Time to time.
Thank you, sir.
Thank you, sir.
Someone made a cell phone on. When you do the cell phone on, it's going to resound. It's even worse than, so you have to use a laptop. Laptop never does a resound. Cell phone does a resound. Thank you for telling, even cell phone better something than nothing. All right. So good. I'm doing all this right now, but other slides are also there. Maybe I'll do it later, right? So far, okay. We are at a 43 slide, another 10 slides. I'll be able to finish it in another 15 minutes, I hope. So you already know it. If you need it, any information, just ask me. This is Bayes theorem, nothing else. I'm not doing anything special. Okay. So A is the event, B is another event, right? So the cost of identifying, not identifying, or dismissing a drug user, okay, that is a false negative. Okay. False negative. A drug user is not identified. So you got negative. But is a really drug user? Is $1,000. Cost of falsely accusing a non-user is given to you. The costs are given to you. False positive. So, and what is the maximum manager should be willing to pay? Okay, for the drug test, expected value of the sample information. So all that you need to do is, so you're testing, not testing. So there are two alternatives here in the first place. If you test it, then it will be positive or negative. You understand me? So, all right. So if it is positive, right? He is a drug user, not a drug user, right? So not a drug user. No test. Could be drug user or not drug user. The probabilities, basically, you know the probabilities. Drug user, not a drug user. Drug user, not a drug user. Okay? So that means the probability that, this is given. This is the condition that you got. Probability of the user given positive. So you tested positive. Is really a drug user. Okay? All right. So 0.62. All right. Tested positive. 0.62. Earlier we found out. See, positive is a drug user. Is 0.62. We found it. So given is a drug user and given positive, tested positive, and he is a drug user. What is the probability of his drug user given positive? See, is a given drug user is given positive by 0.62. If it is not, if it is 0.62, this one is 0.38. Obviously. So, okay. So exactly same way you can actually find out all other probabilities and put the probabilities in there. And then you actually find out. So this one multiply by the probability. This one multiply by the probability. So you get that. Again, this one multiply by this probability plus this one multiply by this probability. And you write down here that value and go in the backward direction. Again, there's a probability for this one. There's a probability for this one. The value that you got multiplied by the positive probability, value you get multiplied probability, and then add them and you write down that value here, and then that get value here. These are two alternatives. And then whichever is the lowest cost, that's what you take. Okay. I don't know if you understood, but I'll tell you. So a drug user, not a drug user. Drug user, not a drug user. Okay. So I'm finding out the probabilities there. Okay. So testing positive, given that he is a drug user, is a priori probability, right? So 0.93. Okay. 0.93 is probability that is testing positive and he is a drug user, given that he is a drug user. Okay. Probability of drug user is 0.05. Not it's a conditional probability. Okay. Light positive, he is not a drug user, 0.03. So joint probability is basically your intersection you're finding out, right? Just multiply both of them, you'll get intersection. Conditional probability means a priori probability multiplied by, you get the joint probability. Okay, you just multiply by joint probability. Okay, but you know what? These are basically two different cases, right? Okay. All right. Sum of the joint probability is 0.075. Okay. Posterior probability. This is, testing positive. Okay. Testing positive with a drug user 0.075, right? You look at that. This is a joint probability. Tested positive, right? The posterior probabilities are, so probability that is a drug user given that is a positive is 0.62. We already found it earlier. So not a drug user, so add them together. Okay, tested positive. This is basically tested positive. Okay. No. No, the other way around, right? Probability that the drug user B1 tested positive. Okay. Then let me go back again and show you 0.62. See 0.62? Tested positive is given a drug user. You have to be very careful about these numbers because so it's easy to make mistake easily. So I came back up to here posterior probability. Posterior means after. Okay. So tested, positive, but he is not really negative. So tested positive, it could be a drug user or not a drug user. So that means add them together, it has to be 1. And you put all the values into your, the system there. See, look at that. Okay. This is given. So he's a user. Okay. Probability of user given positive. Probability of, okay, non-user given positive. And then, you are finding out for the other case, negative case also same way. Okay. And you actually multiply now all of them. Do the math. So 0.62 multiplied by 0 plus 0.38 multiplied by minus 200 is minus 76. You don't minus 76, you write down here. So that's a value of up to here. Okay, now you find out this 0.030038 multiplied by 1000 plus this one multiplied by 0. Add them together and write down here. So minus 0.38 or 3.8, minus 3.8. Okay, the probability of happening that is 0.075. So 0.075 multiplied by minus 76 plus 0.925, this one multiplied by minus 3.8, the total value is going to be that. So that is the decision. One alternative, if you test it. You don't test it, okay? So look at it. So you test it, you get minus 9.21. You don't test it, is minus 50. The best is test it. Okay? If you don't test it, you are going to lose. The difference between these two is the loss that you will have, which is 40.9779. You're going to lose. So that is the value of the perfect information. Okay? So manager should be actually making the testing. You should do the testing. All right. Sensitivity analysis means, basically your decisions are sensitive to, so your some input parameters which could change values. So it's like a what if analysis. So this is again decision tree example again. These are alternatives. Either you do that or do that. So one of them will take, not both. These ones multiply by these probability like a sum product. This one multiply by that, plus this one multiply by that, plus this one multiply, add them together. That's the value here. This one is 40. This value and that value, whichever is better, that's what you put here. And again, the same story. This value, then these are probabilities. 1 by 3, 1 by 3, 1 by 3, right? So 1 by 3 is equal probabilities, 1 by 3. It's not very clearly shown like 1 by 3. So that means 1 by 3 multiplied by, so 1 by 3 multiplied by 0 is 0. 1 by 3 multiplied by 60 is 20. Right, isn't it? 1 by 3 multiplied by 90 is 30. Add them together is 50. I'll write down 50 here. And this one is 40. Okay. So 50 and 40. So highest expected value that you want to take. Okay. 50 you should write. Again, the same story. So 1 by 3 multiplied by minus 45 is minus 15. So this one is plus 15. They cancel each other. 99 multiplied by 1 by 3 is 33. So the total overall is 33. So compared to 40, you take 40. So because either that or this, whichever is bigger. So this is 30. 1 by 2 multiplied is 20. 1 by 2 multiplied is 25. So 45. So you should take 45, not 30. So now there are, this is the 40 multiplied by 0.3 plus 50 multiplied by 0.5 plus 45 multiplied by 0.2. That is the value, expected value of this. So 50 multiplied by 0.3 plus 44 multiplied by 0.5 plus 60 multiplied by 0.2. Add them together, that's what it is. And compare these two, whichever is bigger, that's what you need to take. You understand me? He's just showing you what you should be doing. Overall, the value of this one is 49, this value is 46. Obviously, that is better. You understand me? Hello? Probability of growth is 0.4. Probability of decline is 0.6, obviously. So, positive growth, given as growth, okay? So, consultant report is positive, consultant report is negative. So, if you're really put this into, probabilities chart here, right? Okay. So, the report is positive, there is a growth and decline. The report is negative, there is a growth and decline. So, he gave you the probabilities, you put the probabilities and then the chart and then try to evaluate them. Okay. I don't know you're following or not following, but the lecture notes is written down very, very well. Okay. So posterior probability which are given to you 0.4 and 0.6. So growth and decline. So a priori probability and conditional probability is negative given the growth is 0.35. Okay. I think he forgot to put 0.5 here. 35. So joint probability, you multiply both of them, 0.26. Can you take a calculator and multiply, please? 0.65 multiplied by 0.4. Can you tell me, is it 0.26? Hello?
Yes, sir, it is 0.226.
Okay, good. So thank you for that. So, all right. So joint probability you found out. So the negative case also you found out the joint probability. Positive case, negative case. If I show you one of them, you'll be able to do all of them, right? Okay.
Okay.
So now you actually asking you, okay. I think in the next lecture class, so the more problems, I'll leave it to you, right? So this question, I think probably, maybe I should show you right now. So there's only one problem right now, right? So let's look at it again. At least I'll finish it everything. So we did this already. So economic growth is 0.4. It's like 40% of the time growth occurs. 60% of the time you can decline. Growth doesn't occur. Decline. So that is a priori given to you. Positive report, okay, during economic report is 0.65. So what is it actually? Positive probability of positive given the growth equal to 0.65. Okay. Consultant report negative, probability of negative given decline. So growth complement equal to 0.7. So these are given to you. Okay. So look at it. Positive given the growth. Negative given no growth or decline. 0.7 given to you. So now positive and negative happen, and then growth or no growth. So growth or no growth. You will be able to find out. Okay. So the other way around. What is the probability of positive given the growth? Positive given the growth. Okay. Positive decline 0.7. Okay. All right. So look at it in the next class. Maybe I will explain you this one and then move ahead. No. So basically, you have it's only showing you how to actually compute the probability, the probabilities, posterior probabilities. In the case of growth, in the case of decline, so add them together, it must be 1. These two must be 1. These two must be 1. These are probabilities. That's it. It shows you how to actually do the probabilities. But you can give you the outcomes and then multiply them, add them together, and then find out the overall decision. All right. So I'll leave you there. Okay. All right. I'm leaving you there. So rest of the problems, you look at them. Those are additional problems with solutions. I'll post this video on the web page. Good.